Hello coders, welcome to my channel. So today we are going to discuss a very important and unique topic about arrays that is called as a flexible arrays. So as we know, the arrays are of fixed size. So if we have to define an array, so we can have array, then we have some value over here. So we'll define the number of elements this array can store, and this array will store this memory in a stack. Okay. So if we need to initialize, then we can do like this, like 1, 2, 3. Okay. So here what I have done is I have 20 integer space in array and I am storing only 3. But this 20 is reserved for this array in the stack. Okay. So if I remove this thing, then what will happen? This will automatically be resolved at the compile time, and the array size would be 3 into int, like 3 of the int. Okay, it will automatically do it at compile time. Don't have to specify it. Okay, but these all things, whatever we studied about arrays, that is on the stack and on compile time. So in the large program, we often use structures and we need array in it. Okay. So let's define a structure and let's see what is this variable flexible array. What is a flexible arrays? So I define a struct flex array, that is name of the structure. And inside I will define the size. Okay. And I will define an int array. Okay, like this. I don't specify any value inside it. Okay, so we can extend this array to any number of bytes depending on our requirement. Okay, so if I define any number and trying to check the size of this array, let's see what will I get. So printf, I need to get the size of flex array. It would be percentage %t like this, and we have size of struct flex array. Okay, save it. Let's compile it once and see what is the value. Okay, so you are getting some 84. Let's make it simple. So we have 20 integers. So we have 20 into 4, that is 80. 80 and 4 is this size. Okay, so we are getting the correct number of bytes, and this all things is at compile time. Okay, so if we need to use this array in multiple programs or modules, then this same structure uh, will go with these number of bytes only. So we cannot go beyond these bytes. If we want to go beyond these bytes, then we have to use a point. Okay, but what if I remove this number and get the size of this structure? Let's see what is the value. So it would be 4 bytes only. Okay, so it is taking these 4 bytes only, and it is not taking any byte for this uh, array, because this array is not been defined as the compile time. This need to be defined at the runtime. Okay, so what I will do, I will define the number of elements. So number of elements like 5. Okay, then what I need to do to initialize this structure, what I will do, I will do struct flex array. Okay, then I take a pointer of this. Then I take malloc, and in malloc, what I will do, I will take the size of this struct flex array and multiply by plus the size of array plus the number of elements and size of int. So we have number of elements over here. Okay. And what I will do, I will free this pointer as well. So PTR over here, and I'm freeing it. So once I allocate this memory, okay. So this is a dynamic memory I'm allocating for the array. So this can be done from the pointer itself. If you define a pointer int star of array also. So if I remove this array and make it a pointer, it will work like this as well. Okay. But why I'm using this here? Because this full structure is initialized in one statement only. If this is a pointer, I have to separately first malloc this full array. Okay. Then I have to malloc this pointer array. But here, what I am doing, I am giving the size of a full array, the pointer array, plus the number of elements that I want to store here. So only single malloc command is sufficient to initialize the full array. Okay. And second thing is this memory is consistent. Okay. It will take in the heap memory, but it will be a consistent, not like dynamic memory in which different blocks are present in different memory and they are connected through that pointer. So it's not like that. It will take a full chunk of this memory from the heap itself. So okay, so next thing is what I will do, I'll pointer points to size. What I will do here, I will define the number of elements over here. Okay, then what I will do, I will put the values in this flexible array. So how can I there's value? So I'll take a for loop. Okay, and what I will do here, I will take a counter here. Then we have counter less than ptr points to size. Okay, and then we have counter plus plus. Okay, and now what I'm going to do, I'm just putting ptr points to array. Then we have sorry, counter here is equal to counter plus 1. Okay, so for first element, it will store 1. For second, 2, 3, 4, 5, 6, 7. So this way, it will take till 5 elements over here. From 0 to 4, it will take. Okay, so it will fill the full array with these elements. Okay, so next is I'll print all the elements from this pointer. Okay, this flexible array, you can say. So what I will do here, I'll take printf flexible array elements. And what I will do here, I'll take a same counter better. Okay, and in better, I'll take like this. Same thing. Sorry, I'll do this. And inside, what I will do, I have to print. What I have to print, printf, then percentage d. Okay, space, comma ptr, points to array, points to counter. Okay, so this way we can print the elements within the flexible array. Now it's fine. So okay, so now the size of the flex array is 4 only. Okay, so what I am doing here, I am taking a pointer, giving the memory of this number of elements, and I am printing 1, 2, 3, 4, 5 from these counters. So what we understand from here is by using this flex array, we can make any data type fast in using this. What's the outcome of this is, in spite of using the pointer, we are using the array, which have the advantage being in the continuous memory segments. Okay, so this way we can use this flexible array. If you want to check the real time use case, let's check the next video.